All right, everybody, hello and welcome back. Today what we're going to do is we're going to graph some trig functions. So what I want to do is start off with graphing y equals cosine of x. Just like we do with all of our other functions that we're going to graph, we're going to start off with our parent table over here on the side. All right, so what we need to do is we need to pick some good input values to plug into our function right here. So what that means is we want to pick nice values that we can find the cosine value of, nice angle measurements. All right, so in order to do that, you can really use whatever you want, but to make this as easy for us as possible, I'm going to use our quadrantal angles. So that means 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, again, you could really use whatever you would like, but this allows me to go all the way around the unit circle. Now, what I need to do is I need to evaluate cosine at each of those angle measurements. So cosine of 0 is going to be 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And then cosine of 2 pi is 1 as well. All right, so what I can do is I can go ahead and graph those values now. We've got our input values should be on our x-axis or a horizontal axis, if you will. We have 0, pi over 2. That should be a pi, excuse me. 3 pi over 2. And then 2 pi at the end. Our output values really fluctuate between +1, 0, and then -1. So those are the only values we're going to need on there. And then now I'm just going to plot those points. So we have 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and then 2 pi and 1. And so this is what our function is going to look like. All right, and this function actually would repeat. So we could use some more values here. If we wanted to continue, we could. So for example, I could do 5 pi over 2 next, and then 3 pi, and so on and so forth. And what would happen is this function would just continue to oscillate back and forth. It would continue the wave pattern as it is shown on our graph right there. Okay, the next thing we have to do is our analysis here. The period is really asking us how long it takes for the output values to repeat. And I feel like the best way for us to look at that is look at the graph. I start at 1, so we really want to see how long it takes us to cycle through all of our output values and then go back to where we started. So in this case, from 0 all the way to 2 pi is how long it's going to take. So our period is going to be 2 pi. All right, so I wrote how long it's going to take for our outputs to repeat. The next thing we're going to take a look at is our midline. The midline is exactly what it sounds like, and it is the middle of our graph here. So if we take a look, our output values range from +1 to -1. The middle is right about there. It is a horizontal line at y equals 0. All right, and the only thing that's really going to change that is if we end up shifting up and down, which we will talk about a little bit later. Now, the domain of our function is basically just asking us what values can I plug in and what values will I get out. I guess that would be our range. So we could really take the cosine of any angle measurement we are interested in, positive or negative, fractions, whole numbers, it really doesn't matter. So our domain is going to be -infinity to infinity. Our range is basically asking how low and how high we're going to go, which is from -1 to 1 in this case. And we are going to have square brackets on there as well because we actually touch down at -1 and go all the way up to +1. Now, section really refers to how big these sections on our x-axis are. So if you think about how far apart these numbers are, that is going to be our section. For the most part for us, it is going to be pi over 2. And maybe I'll do that in a different color for us. All right, finally we have our amplitude. The amplitude, or at least one way that I try to remember it by, is the word amp. Sounds kind of like amplified. The amplitude is essentially the stretch factor that we have on our function. So it's the value in front that is going to cause us to stretch vertically. And in this case, it is just 1, so we would say that our amplitude is 1. And this is the graph of our parent function for cosine of x. Now, the next example should provide us with some pretty good information because we've got our transformations here. What I'm going to do is I'm just going to copy the parent table from above, and I will paste it into our new table. And now we just need to apply our transformations. So whenever we have multiplication out in front, remember that that is going to affect our y values. It's going to be a vertical stretch of 2. So I'm going to take all of my y values and multiply by 2. All right, and then we also have some subtraction inside our parentheses that's directly attached to our x value. So that is going to be a horizontal shift. Technically, we call it a phase shift. So this is a vertical stretch of 2. This is a horizontal shift. Right. Pi over 2. Again, because it's a horizontal transformation, it says a minus pi over 2, but really we are going to add pi over 2. It is the opposite. So I'm just going to add pi over 2 to each of these values. All right, and so our new table, which I'll show over here on the side, is going to be, let's just name this one g of x for now. We've got pi over 2, then pi, 3 pi over 2, 2 pi, and 5 pi over 2. And then we'll have 2, 0, negative 2, 0, 2. And again, we just have to graph now. So we don't have anything at 0 in this case because of that phase shift, because we're shifting the original graph over. So that means we're going to start at pi over 2. Then we have pi, then 3 pi over 2, then 2 pi, then 5 pi over 2. All right, and now our range is going to be a little bit different this time because we're going to go all the way up to 2 and then all the way down to negative 2. And I just will plot my points. So we've got pi over 2, comma 2, got pi, comma 0. We have 3 pi over 2, negative 2, 2 pi 0, and then 5 pi over 2, 2. As we can see here, this basically looks the same as our other graph, except we are stretched a little bit vertically and we're actually shifting it to the right, which should make sense given the transformations that we listed. Finally, we just have to do our analysis questions, the characteristics down at the bottom. So first we have the period. So again, how long does it take for us to repeat all of our values? As you can see, we go from 1, I guess 2 in this case, back to 2. And the difference between these two values is 2 pi. Again, that is almost always going to be the case, at least for us right now. The midline is asking us where the middle of our graph is. Well, if we go all the way up to 2 and all the way down to negative 2, the middle is still going to be 0. Now, our domain, well, we only really graphed the specific values in our table over here, but essentially this function should continue in both directions. So it means it goes backwards as well. So it is, again, going to be negative infinity to infinity. And then might as well do the range while we're down here. The range is asking how low to how high we're going to go, and that is going to be from negative 2 to positive 2. All right, I took out this section because we don't really do it that often, but I might as well include it here as well. All we're doing is we're talking about how big each of these sections are, and in this case, they are pi over 2 apart. Finally, we have our amplitude, and remember the amplitude is basically asking us, is there anything that is amplifying or vertically stretching our function? And there is, right? We have a 2 in the front, which means our amplitude in this case is going to be 2. All right, so this is really all we have to do to graph. Now, on the next side, we are going to talk about sine. We're only going to do a couple examples, but for the most part, this is how it works, just like we've done before. We create a parent table, we apply each of our transformations to get our new table, and then we plot those points. All right, as a reminder, our period is how long it takes for the output values of our function to repeat. The amplitude is basically asking us if there's something amplifying or vertically stretching our function in the front. Our midline is the middle output. So in this case, we ranged from 2 to -2, so the middle would be 0. Our domain is asking us what values we can plug in. For both of these trig functions, we can plug in whatever we want. So it should be -infinity to infinity. The sections are really just how big each of these pieces are going to be for us. And so in that case, it is pi over 2. We're really not going to talk about it that much, so it's not entirely necessary for us. And we talked about a range. All right, so let's flip over and briefly talk about sine. So sine's going to work the same way. I'm going to pick some nice values to plug into my function. Again, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, sine of each of these values is going to be a little bit different than what we did before. We're looking for the y value of those coordinates. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And then sine of 2 pi is 0. Just like before, I can go ahead and graph. Got 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Our y-axis are outputs, so we really range from 1 to -1, and now I plot my points. Maybe I should draw that a little bit better for us. So this is the graph of sine. Now, if you notice, it's really just a different portion of what looks like this wave function. All right, it should oscillate between -1 and 1, which makes sense because as our angle measurements, our radians get bigger, essentially we just rotate around the unit circle over and over again, which is why this would just repeat. All right, now let's talk about the period. The period is, again, how long it takes our graph to repeat. So this is one length. We go all the way up, then all the way down, and then back to where we started. So the distance between these two values is 2 pi. The midline is, once again, just the middle here, the middle of our outputs. So we are at y equals 0. Again, we kind of talked about this before, but this function should oscillate in both directions. So that means we can plug in anything. -infinity to infinity is therefore going to be our domain. Our range is going to go all the way down from -1 to 1. And then the amplitude is asking, again, if there's anything we are multiplying by our function that is going to stretch it vertically. In this case, there is not, so it is just going to be 1. Okay? So we're not going to graph this last one, but I do want to talk about it real quick. You know what? Why don't we just do it? Might as well. So I've got a vertical reflection here. And then I've got a vertical shift up 1. So no horizontal changes. So that means I just get to use the same table values that we have above here. So my new table is going to be with our transformations. Nothing happens to our x values, but we have a vertical reflection, which means each of these is going to change signs, which is what I did. Technically, I don't really need the negatives next to zeros, but it helps me kind of make sure I go through the entire list. And then I am going to add 1 to each of those as well. So if I plot those points, well, our x values stay the same. So I've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so I don't really know what happened to the picture of this graph here, but as you can see, we don't have a whole lot of room to work with at the top. So to make this easier, I'm just going to simplify some of these as we go. We have 1, 0, 1, 2, 1. So it means I really need to go all the way up to 2 here. We'll have 0, 1, pi over 2, 0, pi, 1, 3 pi over 2, 2, and then 2 pi, 1. So this is what it's going to look like. All right, so it does look like the graph from above if we were to reflect it vertically and then shift it up 1. I know the graph looks a little bit distorted here because of our axes are a little bit smaller, but the ideas should be the same. It should still look like we're reflecting vertically and adding 1. Now let's talk about our characteristics. Our period is still going to be 2 pi. As you can see, we go from 1 all the way down, then all the way up, and back to where we started. So it's all about once we get to a repeated output. Now, some of us might say, hey, we repeat values right here, but we don't get the full range. We don't go all the way down and all the way up until we get back to 2 pi radians. So although we repeat here, we don't cover all output values. We don't get to the 2 yet until we get down to the bottom. The midline here is going to be a little bit different. If we take a look at our graph, we go from 2 down to 0. So the middle is actually going to be y equals 1. Again, our domain should always be negative infinity to infinity. The range is asking how low we go. Well, we just talked about that with our midline. We are going to go from 0 to 2. And again, brackets because we touch down at 0 and we touch at 2. And then finally, amplitude, which we do have a value in front, but it is really only -1. And so that amplitude, even with the negative, is all about the multiplication. It's the vertical stretch part. We don't really have a stretch there, just a reflection, so our amplitude is still going to be 1. Okay, so this is how we graph our trig functions. We're not really going to get into tangent because it gets a little bit too complicated for the short amount of time we are able to spend on it. But really the important part here is remembering what each of these things mean. The midline is the middle output. Domain is what values we can plug in. The range is what values we get out. The period is how long it takes for our graph, at least that's the way I think about it, to repeat. For us, it's almost always going to be 2 pi. The amplitude is basically asking us if there is a stretch, a vertical stretch in there. I didn't do section this time because we are probably not going to cover it too much, but the sections part is basically asking how far apart each of these values is going to be. And essentially we're looking to see if there's anything that affects that. That means any multiplication on the inside here, which we won't really deal with. And that's all we have, okay? So as always, the process here should be the same as graphing any other function. We start with the parent function, we plot our points and do our analysis, and then we just apply the transformations that we see. We have vertical reflections, vertical shift up. We have a phase shift, which is just a horizontal shift. We are not really going to do any horizontal stretches or shrinks, if you will, but we do have a vertical stretch out in front. Okay? As always, if you have any questions, please feel free to let me know, and thank you for listening.